The first question on the test will be about projectile motion. What is the acceleration of an object on Earth when thrown in the air?
The acceleration is 9.8 meters per second squared, or approximately 10 meters per second squared. This means the vertical speed will change by 10 every second. If an object is thrown down with an initial speed of 2 meters per second, the speed will increase by 10 every second. So in 1 second, it would be 12, and in 2 seconds, it would be 22.
If an object is dropped from rest, that means the speed is initially 0. What is its speed in 5 seconds?
The vertical speed increases by 10 every second. In 5 seconds, the speed will increase to 50 meters per second.
If an object is thrown upward with a speed of 70 meters per second, how long does it take to reach the highest point?
It takes 7 seconds. At the highest point, the speed is 0. If the initial speed going up is 70, and the vertical speed decreases by 10 every second, it will take 7 seconds for the speed to slow down to 0.
If an object is thrown downward with a speed of 70 meters per second, in 2 seconds, what is its speed?
The speed will be 90 in 2 seconds. The initial speed going down is 70. The speed will increase by 10 in 1 second. In 2 seconds, the speed will increase by 20. So, speed in 2 seconds will be 70 plus 20, which is 90.
So what's going on is you're throwing it down at 70 meters per second. So it's going faster than when you just drop it from rest. Okay, now for every second, the speed will increase by 10. So in 2 seconds, it will increase by 20. So at the end of the day, in 2 seconds, you end up with 90 meters per second. Now we're moving on to the second part of the review for the final. And you're going to answer questions about Newton's law, momentum, and energy. Newton's second law states that F equals ma. Explain what each variable represents.
F represents force, m represents mass, and a represents acceleration.
If a force of 40 newtons is applied to a mass of 5 kilograms that is initially at rest on a frictionless surface, what would the acceleration of the 5 kilogram mass be? The force will equal the mass times the acceleration. So if the mass is 5, what times 5 will give you 40? Well, that's going to be 8. Okay, so since 40 is equal to 5 times 8, the acceleration is going to be 8 meters per second squared. A 5 kilogram block that is initially at rest on a frictionless surface is hit by another 5 kilogram block moving at 10 meters per second. If mechanical energy is conserved, what would the kinetic energy of the two-block system be after the collision? Conservation of mechanical energy. The only mechanical energy in this system happens to be kinetic energy. The kinetic energy comes from the movement of the boxes. And the equation for the kinetic energy is 1/2 mv squared.
But, teacher, why does it say frictionless surface? But, teacher, why does it say friction?
If the surface isn't smooth, it would slow down the system and convert the kinetic energy to heat energy produced by friction. That would mean that the mechanical energy will no longer be conserved.
Where do we find frictionless surfaces?
Where there's ice. So let's pack up our stuff and fly off to where there's ice. The two 5-kilogram blocks are on a frictionless surface.
To determine the kinetic energy of the moving block, we use K is equal to 1/2 mv squared. In order to work out the formula, we have to plug in the correct numbers. M represents mass again, and the mass is 5 kilograms. The V is for velocity, which is the same thing as speed in this case, and the speed is 10 meters per second. Don't forget to use PEMDAS, which means that you're going to work out the exponent first. So you have 10 squared, which is equal to 100 because 10 times 10 gives you 100. Once you work out the 100, then you multiply that 100 to a 5, and then you multiply it to the 1/2. Okay, so you'll end up with 250 joules for your kinetic energy. So the kinetic energy of the moving block only is 250 joules. Now let's look at the block that's at rest. When anything's at rest, the speed or the velocity is equal to 0. So we use the same formula, K is equal to 1/2 mv squared. The mass for the block at rest is also 5 kilograms. So we're going to plug in 5 into the M. But since that's at rest, the velocity will be 0. And so we're going to plug in 0 into the V for velocity. Once we plug the 0 into the V, if we square 0, we get 0. And then if we multiply that 0 to the 5, we're going to get 0. And then 0 times 1/2 will equal to 0 also. So the kinetic energy of the block that's at rest will equal to 0 joules. To find the total energy of the system before collision, we have to add the 250 joules for the 5 kilogram box that's moving, and the 0 joules for the box that's at rest. And 250 plus 0 gives you 250 joules total. Now we're going to move on to the last part of the review for the final. What would the momentum be, or the total momentum be, of the two block system after the collision? The law of conservation of momentum states that the momentum or the total momentum is conserved as long as there's no external force on the system. And another thing to note is that we use the letter P for momentum, and the equation for momentum is P is equal to mv. So M represents the mass again, and it happens to be 5 kilograms because it's the same scenario. And for the moving box, the speed will be 10 meters per second again. For the block that's at rest, it's going to have the same mass, so it'll be 5 kilograms. We use the same equation, P is equal to mv. The velocity, since it's at rest, guess what it is, folks? It's going to be 0 once again. The total momentum of the system before and after collision, since momentum is conserved, it means it's the same before and after. The momentum of the moving box was 50 kilogram times meters per second. And then we add the momentum of the block at rest, which was 0, and you total it up to get the total momentum, which happens to be 50.